Hi everyone. So now we'll start with tokenization first because that's the first step for a transformer. How it actually works is because a computer cannot understand word by itself. It basically breaks it into a binary segment, binary encoding, so that it could read the binary numbers and then translate or reply in again a binary format which gets decoded into the words. So this is how it works. So basically word in any computer, not just the transformer but any computer, it goes, it cannot go like that. Okay, so what happens is word gets converted into number, sometimes binary, which then goes to a computer. The computer understands it, calculates whatever operations that it needs to do, then generates a number, which again then generates a new word or same word or whatever. So that this process to convert a word into number so that at least we could process it is called tokenization, right? Is called tokenization. Okay, now there are multiple ways we could do tokenization, starting with let's say, now there are different methods for tokenization: word based, another one is character based, then the third one is sub word based tokenizer. Now there are these three different types of tokenizers: word based, character based, and sub word based. Word based simply means, for example, if I have a sentence, let's say, which says the city is beautiful, for example, the city is beautiful. For example, let me just write here, the city is beautiful, right? Now a word based tokenizer will basically be saying that okay, this is a different word, city is a different word, is a different word, beautiful is a different word. So we'll be having four different tokens. So that's it. That's what the main tokenization is all about. Let me just clean this up. Okay, so what it does is, word based tokenization is basically uh, segmenting a sentence based on the words. The city is beautiful. Now this is one token, second token, third token, fourth token. Versus uh, in a character based tokenization, it basically means, I'll just rewrite it in a character based. How it is it's based on every individual letter. So if it's the, it breaks into T, H, and E, three different characters. Now this was an easy method, like just split it based on the tokens. But what happens is there are certain drawbacks for a word based and character based tokenization method. Certain drawbacks are there. Now what are those drawbacks? Now one of them is basically, for example, there's a word called learn. Okay, it could be also written in English. It could have multiple ways of writing learn. For example, learning, which is a continuous tense, I could have written learned and learned. Now, as an LLM, I want a relation between these three words: learning, learned, and learned. But the only problem is we don't have any relation in these. So that's one drawback. Another drawback is, for example, there are certain words like a, and the, these are called filler words. Now what happens in an LLM is they consume, because in a paragraph or in English, or like English in a paragraph or in a big passage, they would not capture a meaning by themselves, but they are important again, so they cannot be removed always. Of course, as stop words they could be removed, but sometimes they also capture a context among a sentence. Now, because of which there's a problem, that because these are words are common and in a large amount of value, they consume a lot of they consume a significant amount of memory when we load it into the context as a data. But they by themselves do not have any meaning, so it becomes an how do I say, excess significant memory consumed, which is another drawback, right? uh, Third one is, for example, spelling mistakes. This was second. Let's call it filler words. Third one is spelling mistakes, which basically means if, for example, pattern. For example, pattern is a word, and if someone say pattern, okay, by mistake, then for a word based tokenization, these word is a different, this word is different. So it becomes hard for an LLM to understand, okay, these two words are different, and thus these two words are given different tokens, which basically means we have now a large number of big vocabulary and good number of tokens involved for explaining same meaning word. So that's one, that these are the three major problems in word based tokenization. Now moving ahead on the character based. The good part for having this tokenization method is the vocabulary size decreases. It's a small vocab, uh, because we in the vocab will contain all the special characters, will have all the alphabets, which is A, B, C, D, will have special signs and symbols, and so it will be a small vocab at the end of the day. But what happens is, uh, of course, this vocab size decreases, but the context length increases, because now we have more number of tokens for a single word. For example, let's say there's a word called happy. Okay, now each of this word will be a token, HAPPY. Okay, so because now we have 1 2 3 4 5 tokens explaining one single word. That's a drawback, because now we have huge context length. Also, another thing which majorly is, it loses a pattern of language. So because we have tokens defining an individual character and not as a word, not a complete word as a meaning, so we miss on that. So then we have something called as as a solution, the best solution until now is sub word tokenization, which basically means instead of breaking a word in a sentence word by word or character by character, will basically split the word based on reasonable meaning and such that it does not oversize on the context, contains good number of tokens, decent number of tokens, reasonable vocab size, and small context. For example, modernization. What we could say is modern is one word and ization is another token. Okay, so we'll have now two tokens. So now we have a reasonable vocab size. We can handle new words as well. For example, the same example, pattern. So instead of pattern, if someone says pattern, at least the first word is already captured in the same thing, and this is another token anyways. So of course, because of subwords, we can handle spelling mistakes and new words as well. Also, we have small context length, which was a drawback in character based tokenization, where happy, which was a 1 2 3 4 5 letter word, was defined by a 4 token set. Same goes with this one, but this one is defined under only 2 token set itself. So we use a subword tokenization method currently. But the question is, how would you split these? How would a word be divided? Of course, why did I decide to do it 1 and 2? I could have written it mod organization, 3 different tokens, or I could have divided it into 4 different tokens. So there is something called as byte pair encoding, which was the base concept from which we thought, okay, this is the best split in a word that we can do. Now, before we do go back on how byte pair encoding is used to define what would be the split, let's understand byte pair encoding, what it basically means. So now byte pair encoding was used in compressing a text passage or text document. How it works is, for example, there's a very common example saying AAA, BDA, AABAC. Okay, now what byte pair encoding says is, we'll first try to make pairs. Whichever has the highest pair, then we'll replace that pair with a different character which does not exist in the vocab until now. And then we'll keep on doing it until we reach to the smallest range which cannot be further splitted up. So we are in a way removing duplicacy in a word. For example, AA or AA or AB or BD or AA or AA or AB, BA, AC. So these are different pairs. Okay, now we see that, okay, AA is the pair which has been repeating 4 times, almost 1 2 3 4. It's the highest number of token pair combination. So let's just replace AA with Z, for example, because Z does not is not there in the vocab until now. So we'll write Z, and then we'll write remaining as A, B, D, then we'll again write Z replacing these two, and then again A, B, A, C. Okay, now we'll try to find combinations again. So now considering combinations, ZA, AB, BD, DZ, ZA. So ZA we know is repeating two times. Now ZA is two times. AB is also repeating two times. BA and AC. Okay, so now we know that okay, AB is repeating two times, ZA is repeating two times. We'll replace AB. So now in the same dictionary, let me write in the same color. AB is replaced with let's say Y. Okay, so now what we have is Z, then we'll write Y. Okay, and then coming back to Z, Y, B, then again the old Z, then again AB is replaced by Y, then again A, C. Okay, now we'll just again do the same thing, pairing ZB, sorry, ZY, YB, BZ, ZY, YA, AC. So we see that here ZA, ZY, sorry, ZY is repeating two times. So now this becomes, sorry, so now we'll just rewrite it. We'll just say okay, now ZY is replaced with, let's say let's say X. Okay, so now it becomes X, B, then X, then A, C. Okay, now it cannot further be splitted. So a word which was 1 2 3 4 5 6 7 8 9 10 11 11 character word, an 11 character word has gone to 1 2 3 4 5, a 5 character word. So a single word has been shrinked to a 5 character word. Now I just have to go in a reverse order if I want to decode it. For example, X will become ZY, B, ZY, AC. Okay, then my AB, my Y becomes AB. So Z, A, B, B, A, B, A, C, and then my Z becomes AA. So I'll just scroll this up and AA, AB, AAAB, D, A, DB, AAA, BAC. Okay, so I just have to go in a reverse order to basically decode it back. So that's the complete concept of byte pair encoding. It is just to reduce the file size, text file size, and compress it. So this is how the byte pair encoding was used until GPT as a text compression method algorithm. But now what we do is we basically use it for byte pair encoding. We use it for tokenizing a sentence. So I'll just show you one small example of how currently a sentence is tokenized. Just give me 1 second. I hope my screen is okay. Screen is not visible. Just give me 1 second. I hope it is visible now. I just search, take tokenizer, and then we'll go to. So this is how it does. For a you are a helpful assistant, it basically uh, the color combination that we are seeing here on the screen, this is how it does. It's all tokenized. These are all tokenized in this way. You are a helpful assistant, and so this is how it is tokenized. Okay, now in different algorithms, it's a different way they are splitted. For example, if I change the model, GPT-5 3.5 turbo, it's in a different way of tokenizing. So basically, this is how a tokenization works. It's just to split a word into tokens.